All right, next we have stratified random sampling. Remember, students mix up stratified and cluster the most, so please make sure you're paying attention. Simple random sampling is not the only fair way to sample. If your population or sampling frame is large, an SRS is not easy to complete. So doing a simple random sample is not always going to be your easiest method, and there are other fair techniques. Stratified random sampling is when you first break your population or frame into groups. Now, internally homogeneous groups mean that each group internally is alike in some way. So you're breaking your groups according to some characteristic called the strata. And that's sort of a word you might see from here to here. It's why we call this stratified. This is just it's an English word that you probably don't know very well. For example, we may break our population into gender, boys and girls, or we may break them in by age, or we may break them by an ethnicity or by social class, so that you have boys over here and girls over there. So when you start breaking people according to these traits or these strata, you should already be feeling like, whoa, that's not kind of fair to have them separated like that. But that's where this important step comes in. The important step is to randomly, gotta have randomization always, randomly select individuals from each group. When you try and decide if it's stratified or cluster, you need to ask yourself, well, wait a minute, are they selecting from each group? And if they are, that is stratified. And if you think about it, if you split it into boys and girls and you randomly select boys and you randomly select girls, then you're kind of ensuring that each group is represented in the sample. You're making sure boys and girls or both have representation in the sample. You don't have to pick the same number of boys and girls or same number of people from each group. For example, if you know your population has 80% boys and only 10% girls, then you can sample only of your sample 80% from the boys and 10% from the girls. But if you do an SRS, then you might not get any girls. That would be possible. And so they might not be represented. So in stratified, you're kind of ensuring that both genders or groups or whatever you're talking about is represented. If you are ever told that in like an AP problem or anywhere that you feel boys and girls may differ from each other in opinion, or if any groups of people may differ from each other in opinion, for example, we got a lot going on with immigration. If you feel that people of a certain ethnic group may feel differently if you're trying to ask questions about immigration, then you must make sure each group is represented. And that's where stratified sampling should be used to thus ensure each group is represented. All right, for example, you're trying to find out what freshmen think of the food served on campus. Food services believe that males and females typically have different opinions on the importance of the salad bar. So if you feel that way, you should be using stratified sampling. How should you adjust your sampling strategy to allow for this difference? So you're going to want to make sure that we use stratified sampling. So we should first separate the freshmen into boys and girls, and randomly, remember you always need randomization, select students from each gender. And you'll probably use an SRS to do that selection. That's the random part, but you're breaking them into groups, thus making sure each gender is represented. Now, that is going to sound very similar to cluster sampling. Sometimes stratifying isn't practical and simple random sampling is difficult. Cluster random sampling is when we break the population into internally heterogeneous groups and then randomly select whole groups to be our sample. What internally heterogeneous means is that each separate group is not all alike in some way. Internally in the group, they're all kind of different. So what that means is the groups themselves are representative of the population. That's really important that you make sure each group is actually a little mini population. So if your population may have a cluster of people here and a cluster of people here, and sometimes your clusters might be geographically arranged, like we have neighborhoods in Mooresville, like these could all be little clusters. And instead of picking from each, because that's what we saw in stratified, we picked from each. What we're actually going to do now, if I say I number all these clusters, 1, 2, 3, 4, 5, 6, 7, we're going to actually pick whole clusters. So I go to a random number table and it picks cluster 5. Okay, so everybody in this cluster right here, you're now in my sample. You could pick more than one cluster, but that's the basic idea. You don't pick from each like stratified. You pick whole clusters or clusters, randomly, of course. You've got to make sure every group is representative because you don't know which group you're going to get. We randomly select a whole group or groups, not from each group as in stratified. For example, still same freshmen trying to figure out how they feel about that salad bar. You've considered an SRS and stratified. Now you have run into a problem. It's simply too difficult and time consuming to track down the individuals whose names were chosen for your sample. Fortunately, freshmen at your school are all housed in 10 freshman dorms. So they're all living in these dorms. How could you use this fact to draw a cluster sample? So what we could do is we could randomly select a dorm, and it can be more than one, so it could be or 2 or 3, however many people you're looking for, and survey, which just means like ask those freshmen, survey all freshmen living in those selected dorms. So now it's kind of like taking your sampling frame, they're all split into these dorms, and we're just picking randomly, of course, a dorm or more than one dorm, and we just go and survey those people. So that's a sample from our population.